The numbers from 1 to 10 have to be placed in the small circles, one in each circle. Numbers in any two neighboring circles must have the same sum as the numbers in the two diametrically opposite circles. Some of the numbers are already placed. What number should be placed in the circle with the question mark? This is the wheel where the numbers are from 1 to 10. Some numbers are visible, some are hidden. We have to find what number will be in this question mark. The condition here is that the two diametrically opposite circle will have the same sum. So for example, if we have 9 and 5 that sums to 14, then diametrically opposite is these two, then their sum should be 14 too. We already have 10. What is remaining is 4. So the 4 will be replaced on this empty circle. Now let's move ahead and find the sum for these two circles. So diametrically opposite are these two in here. So we already have two numbers here which sum is 11. Here we have 5. So what is missing is 6. So it gives 11 as well. Now let us move ahead and see between these two numbers and diametrically opposite is this 2 here. So we have 6 plus 2 gives 8. And here we already have 1. So what is missing is 7. Now let us see. We have number 1, 2, 3 is not there. 4 is there. 5 is there. 6 is there. 7 is there. 8 is not there. And 9 is there and 10 is there. So there are two numbers remaining, 3 and 8. And we have two empty cells, this one and this one. So the sum of this two here and here should be same, and we have two numbers left. So if we put 3 in here, so 9 plus 3 gives us 12. And if we put 8 in here, 8 plus 4 gives us 12 as well. So these are same. Number replacing question mark would be 3. So our answer is option A, 3. Problem 12. Emmy glues 6 stickers shown onto the faces of a cube. These are the 6 sticker faces. The picture below shows the cube in two different positions. Which sticker is on the face opposite the face with the mouse on? So we have to find opposite face to the mouse. So if we will observe this shape, we would know the ladybug has been turned clockwise. So when it is turned clockwise, duck will come at the bottom. So duck is here at the bottom, and mouse will come this face. So that is opposite of the dog. That means the opposite to mouse is dog. That is option D. Problem 13. The diagram shows 5 paths from X to Y marked with a thick line. Which path is the shortest? So here we have to find the shortest path traveled on this thick line. So we have 3 circles, a large, medium and small. There are also paths or the bridges between this circle that people walk across. The actual size of the circles does not matter. What matters is the distance traveled along each one. To measure the distance, we will assign a value 1 to each quarter of a circle and 1 to each bridge. Then we will add these values to find out which route is the shortest. Let us use this strategy and solve this problem. So let us name L for large circle, M for medium circle, and small for small circle, and a bridge for B. Option A has 2 large, that is 1 and 1. Medium has 1 and 1, so that is 2 as well. And small is 2 as well. So small is 2 as well. And now count the bridge. So we have 1, 2, 3, 4, 5 bridge. We mark it as 5. Similarly, option B, we have 2 large, medium, we have 2 medium, small, we have 1, and bridge, we have 5. The sum of this is 11. Sum of this is 10. Option C, we have 1 large, 2 medium, 2 small, and we have 4 for the bridge. That gives us 9. Option D, we have 2 for large, 2 for medium, 2 for small, and 5 for bridge. That gives 5, 7, 7, 9, 9 plus 2, 11. Option E has 2 large, 2 medium, 1 small, and 5 bridge. That makes us 10. The smallest sum we got is 9. That is option C. The shortest distance traveled is on shape C. Problem 14. A father kangaroo lives with his 3 children. They decided on all matters by a vote, and each member of the family gets as many votes as its age. The father is aged 36 and the children are 13, 6 and 4 years old. So the father always wins. How many years will it take for the children to win all votes if they all agree? These are our options. So what happens each year? Every year, everyone gets 1 year older. That means everyone gets 1 more vote. So the father gets 1 new vote each year. The kids together gets 3 new vote. So let us solve this problem now. So initially the father is 36-year-old. Kids are 13, 6, 4. That totals to 23 years. That means they will have 23 vote. After a year, father will be 37, kids will be 14, 7 and 5. That totals 26. They will increase by 3 vote. Father will be 38, kids will be 15, 8 and 6. That equals 29. They increase by 3 vote. 39 father will be, it will be 16, 9, 7. That equals to 32 vote. Father will be 40, will be 17, 10, 8 goes to 35. Father will be 41, kid will be 18, 11, 9. That increased to 38. They are nearing now. They will be 42, 19, 12, 10, and the vote will be 41. So here we are nearing to the father's vote. So father becomes 43-year-old, kids 20, 13, and 11, which sums to 44. So this is the age and the time when kids will win the vote. So how many years it took? It took from here to here, 1, 2 year, 3 year, 4 year, 5, 6 and 7. So it will take 7 years for kids to win the vote. So now this was a simple way. Now let us do some maths here. So this is an option 1. You can solve through this or you can use some maths. So we know that every year we get 1 year older. That means everyone gets 1 more vote. The father gets 1 new vote each other. The kids together get 3 new votes. That means each year the kids gain 2 more votes than the father. Now how many more votes do this kids needs to catch up? Right now the father has an initial 36 votes. The kids has 23 votes. They are far from 13 votes. Since the kid gained 2 votes on him every year, so we divide 13 divided by 2 gives us 6.5. Since we cannot have half a year in the case, we round up to make it 7. So it will take 7 years for the kid to have more votes than the father. So this is our option C, 7. Problem 15. The picture shows the friendship of 6 girls and Patricia, Chloe, Dinah, Elizabeth, and Fiona. Each number represents one of the girls and each line joining 2 numbers representing a friendship between these 2 girls. Chloe, Dinah, and Fiona each have 4 friends. Patricia is friends with only Chloe and Dinah. Which number represents Fiona? This picture represents friendship of 6 girls and these are our options. Let's represent N as A, Patricia as B, Chloe as C, Dinah as D, Elizabeth as E, and Fiona as F. So from this question we know Chloe, Dinah, and Fiona each have 4 friends. Patricia has 2 friends and they are Chloe and Dinah. So if you see this picture, we see that number 5 is the only one with 2 friendship lines. So that could be Patricia. Now the question says Chloe, Dinah, and Fiona each have 4 friends. So the number 1 represents 4 friendship lines, number 3 represents 4 friendship lines, and number 4 represents 4 friendship lines. Since Patricia is friends with only Chloe and Dinah, that means these are Chloe or Dinah, Chloe or Dinah. Now there are only 3 numbers which represents 4 people friendship. Chloe and Dinah already have their numbers 1 or 4. Number 3 is left, so that means 3 is Fiona. So our answer is option B, 3. Problem 16. An elf and a troll meet. The troll always lies, while the elf always tells the truth. If they both have just said one sentence, which one could the sentence be? These are our options. Now from question we know that we have elf who always tell truth and we represent it with T. We have troll who always lies. So we represent lie statement as F. So if any of the statement they said follows this pattern, that could be just one sentence and that could be our answer. Let us go through this option one by one. Let's see option A. I am telling the truth. So if elf says I'm telling the truth, this is true. If troll says I'm telling the truth, trolls always tell lie, that is a false statement. Option B. You are telling the truth. If elf says this to the troll, it's a lie. So that is a false statement. But elves can't lie. If the troll said this to elf, it is true. But troll cannot tell the truth. So this is an impossible statement. So option B is not our answer. Let's see option C. We both are telling the truth. If the elf says it, but the troll is not telling the truth, they always lie. So the elf statement would be false, which is not allowed. Elf always tell the truth. If the troll says it, it would mean both are telling the truth, but trolls lie. So it must be a false. So they lie. But this is not the combination we are looking for. So this is not our answer. So option C is not our answer. Let's try option D. I always lie. If the elf says this, it's a lie. Elf can't lie. So that is a false statement. If the troll says I always lie, yes, they will lie. But they can't tell the truth. Impossible. But they are telling the truth here. So this is not a combination we are looking. So again, option D is not our answer. Now let us consider option E. One and only one of us is telling the truth. If the elf says this, then it is true. It means only the elf is telling the truth and troll is lying. If the troll says it, this means they are telling the truth, but trolls can't tell the truth. So this is not the combination we are looking. So option E is not our answer. So correct answer here is option A. I am telling the truth is the only the one sentence which both have said. Problem 17. We call a three-digit number nice if its middle digit is greater than the sum of its first and last digits. What is the largest number of consecutive nice three-digit numbers? The condition for a number to be nice is that the middle digit must be greater than the sum of the first and last digits. Let's take an example. Consider 391. First digit is 3, middle digit is 9, and last digit is 1. If it is nice, that means 3 plus 1, which is 4, must be less than the middle digit, or the middle digit should be greater than 4. Now the question asks, what is the largest number of consecutive three-digit numbers? Let's try to maximize the number of nice numbers in a row. To do this, we want the middle digit to be as big as possible and the first and last digit to be as small as possible. And this is the trick, because that way the middle digit will more likely be greater than their sum. So let's use 9 as the middle digit and start with the smallest first and last digit. So smallest could be 0 or 1, but we cannot keep 0 because it will not consider as three-digit number. So we keep 1 and then 0. So here we have the middle digit is greater than the sum of first and third digit. Let's consider another one, 191, 192, again 193, 194. Sum is again less than 9, 195, 196, and 197. So sum is 8, which is still less than 9. But if we do 198, that would be equal. So we would cancel this. So the number from 190 to 197 will be considered as the consecutive nice three-digit number. So our answer is option D, 8. Problem 18. Mary has exactly 10 white cubes, 9 gray cubes, and 8 dark gray cubes, all of the same size. She glues all these cubes together to build a big cube. One of the cubes below is the one she builds. Which one it is? These are our options. Mary has built a perfect 3 by 3 by 3 cube. That means it should have 27 cubes. All of the cubes are 27. Now we know that Mary has built 10 white cubes, 9 light gray cubes, and 8 dark gray. Let's look at each option one by one. So option A. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 dark gray cubes. But we have 8 in here, so this is not our option. Let's have option B. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 light gray cubes, which is correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 white cubes. So this is more closer to it. This could be our answer. Let's try option C. Let's count white cube. We have 1, 2, 3. So this is 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 10 white cubes, so this is not our answer. So let us consider option D. So we have 1, 2, 3, 4 dark here, 5, 6, 7, 8, and 9. So we know we have 8 dark gray cubes, so this is not our option. Option E. Let us count the light gray cubes. So we have 1, 2, 3, 4, 5, 6, 7, 8, here 9 and 10. So Mary has 9 light gray cubes. So this is 10. This is not our answer. So our answer is option B. That is the one cube which Mary has built. Problem 19. What does the object in the picture look like when viewed from above? This is the main picture and these are our options, and we have to find out which option matches the correct connections between them. So we are given a ring of pipes with a pattern at the top and a structure at the bottom, and they are connected with a series of pipes. And we need to figure out which option matches the correct connection between them. So let us observe the top ring. At the top, we can see clearly that there are alternate patterns. So light gray pipes are connected in a repeating order. So any correct option must follow that light gray pattern. So we see that all the patterns follow that. So let's move on to our second observation. Let's look at the bottom structure. Now at the bottom part, we have 2 black pipes, then 2 gray pipes, then we have 1 black and 1 gray. So if we observe the bottom, we see that all have the similar patterns. So now let's move on to our third observation. Now let's look at how these are connected to the top. So whenever 2 black pipes are connected, they go in the black, gray, gray. So that should be followed in all the options as well. And if not, then we'll eliminate the wrong options. So let's check option A. So we have 2 blacks and they are connected with black, gray, gray. We have 2 blacks and they are connected with black, gray, gray. That is also followed here. We had 2 blacks and they are black, gray, gray. Perfect. We have 2 blacks in here and it's black, gray, and this is wrong. So this is not our answer. We have 2 blacks and it's gray, black, gray. That is not our answer. So we eliminate option E, option D. Now let's focus on how the 2 gray pipes are connected. So we know that the gray pipes are connected as black, black, and gray. So let's see. 2 gray pipes are connected black, gray. That is not what it is. So this is eliminated. Let's see option B. So two gray pipes are connected with black, black, gray. So this could be our answer. Let's see gray in here, gray in here. It should be black, black. So this is gray. It's not our answer. So our answer is option B is what it should be viewed as. Problem 20. Magnus has to play 15 games in a chess tournament. At some point during the tournament, he has won half of the games he has played. He has lost 1/3 of these games and 2 have ended in a draw. How many games has Magnus still to play in the tournament? These are our options. So we need to figure out how many games are left to Magnus to play. Let us get a clean slate. Let us assume that Magnus has played X games so far. He won some of the games, he lost some, and there are couple draws. So he has won half of the games. That means if he has played X games, then X by 2 games has been won by Magnus. He has lost 1/3 of these games. So if he has played X games, then he has lost X by 3. And 2 have ended in a draw. So we have 2 in a draw. Now when we add this, we are getting the number of the games he played, which is, we assumed X. Now we take the least common factor of it, which is 6. We solve the fraction, we get 3x plus 2x plus 2 gives us x. We get 5x by 6 plus 2 gives us x. So we take fx here on this side, and it becomes 2 equals to x, and changes the sign, f by 5 by 6 x. So we multiply by 6 on both sides. So we get 2 multiplied by 6, 6x minus 5x, because this 6 cancels. So we get 12, 6x minus 5x, 12 equals to x. So he has already played 12 games. But he is supposed to play 15 games. So how many are left? 15 minus 12 gives us 3 games. So Magnus has to play 3 games in a tournament. So our answer is option B, 3. With this, we wrap up part B of 2020 Math Kangaroo challenge for grade 5 and 6. If you enjoyed this challenge and learned something new, don't forget to give this video a big thumbs up and subscribe for more fun, tricky, and exciting math adventure. See you in part C of this video series. Thank you. Bye.